Good morning, students. I am Katyani, lecturer in Electronics and Communications, Department of Collegiate and Technical Education. Today we will discuss the 15th session of Unit 2, Instruction Set and Assembly Programming of 8051. The course is Microcontroller and its Applications, 3rd semester, Diploma, and the course code is 15MC3040. The program is Mechatronics and Engineering. So, what we have discussed in the previous session? So, we have discussed the addition of three 8-bit numbers. And also we had discussed counting the number of zeros and ones in the two consecutive memory locations. What was the logic used? So in the first program, just we used to add three 8-bit numbers incrementing the memory pointers and storing the result at the destination and checking whether carry flag is set or not. If carry is set, then we used to increment the higher upper byte, otherwise we used to not increment the upper byte. So what was the logic used in counting the number of zeros and ones? So we used to rotate the contents of the accumulator. So if carry is set, then we used to increment the ones loop, ones memory location, that is contents of data in the ones memory location. If it is 1, if the carry flag is reset, if it is 0, then we used to increment the content of memory location that is having a count of zeros. So today's session we will have the programs to convert unpacked BCD to 2-digit packet BCD and also conversion of 2-digit packet BCD to unpacked BCD and ASCII to 2-digit packet BCD to ASCII. BCD is binary coded decimal. ASCII is American Standard Code for Information Interchange. So now let us discuss the first program to convert unpacked BCD to 2-digit packet BCD. What is this unpacked and packed? Yes. So unpacked means, it will be if I provide 6 and 3, this is unpacked data, then I should get packed data, that is 63. So 6, if I provide 6 and 3, then my output should be 63. So here they have not mentioned any memory location or where the data has to be stored. So hence it is up to the user. So I am assuming that let me provide the data at memory location 30H and 31H to unpacked BCD numbers and I have to convert into packet BCD digit. So I am giving two unpacked numbers at 30H and 31H and I am expecting my result at 40H memory location that is packed data. So this is my requirement. So what is my initial settings? So that is I will start with the origin. So here I am giving one of my data at memory location 30H. So hence move A comma 30H. So I am taking the data into my accumulator. So what is the logic behind this? If I provide 6 and 3, I should get 63. What is the logic behind this? Say, yes, you have to change this to, so you have to swap these nibbles so that it gets swapped, and after swapping what you have to do, you have to perform OR operation between this, so you will get the packet BCD. So what happens here? So first I am taking the data into my accumulator, 30H contents, that is 6H will be taken, and then I am going to swap it. So this 6, if I swap, it becomes 60. So 60. So next I am swapping it and then I am performing OR operation between contents of accumulator and the next data, that is 31H contents, that is 03H. So if I swap, it becomes 60 and now if I add it, it becomes 60 plus OR operation will give you 63H. So this is how I am converting unpacked BCD to 2-digit packet BCD. So let us check this with the example. So I am starting with origin. First what I have to do, I have to take my data. So where is my data? So my data is at, according to this, so my data is at memory location 30H, that is direct addressing. So that data will be taken and that data has to be, so I will take my data, move A comma 30H. So I have taken the data. So first data is 06H. Now what I have to do? 06H has to be swapped so that it becomes 63, 60. 6 has to be converted to 60. So that is why what I will do, 6 has to be converted to 60. So what I will do, I will swap the lower nibble with the upper nibble. So now I have in accumulator 60. So now let me store it in the destination, that is move 40H comma A. I am storing it at memory location 40H. So temporarily I have to save it in some location. So next I will take my next data, that is move A comma, what is that, 31H. Next data I am taking 31H. Now what I have to perform? I have to perform OR operation between these two. What are the two? Yes, it is OR operation between A and where I have stored the previous data, that is at 40H. Now I have to store the result at the destination, that is move 40H comma, and I will use so this is what it operation performs. So here they have directly ORed the accumulator contents with contents of 31H and then they have stored. Otherwise, we can also perform like this. I am storing the result temporarily at some memory location and then taking the next data in the accumulator and then performing the logical operation between them and then storing. So now let us go to the debugger session. So where I am planning to give the inputs at 30th memory location, unpacked BCD. So I will give 06H and 03H. What should be my output? It should be 63. Where I am expecting my results? At 40th memory location. So let us see what happens. So first the data is copied into, my data is 06. 06 will be copied into accumulator. So 06 is copied into my accumulator. So what is my next instruction? I have to swap that. So next I have swapped that. 06 becomes 60. It has become 60. What is my next instruction? I am storing it at memory location 40H. That is my next instruction. So next data is 03. Next data is 03. I am taking it into accumulator. Now I am performing OR operation between accumulator and that. So what is after OR operation? Accumulator should get 63H. Yes. Now I have to store that 63H into my result memory. So my result memory is 40H. So if I give 6 and 3, my output should be 63. So this is program to convert unpacked BCD to 2-digit packed BCD. Next is program to convert 2-digit packed BCD to unpacked BCD. So here what they will do, they will give you packed BCD. Say for example, they will give you 63 and you have to convert that to 6 and 3. So how will you perform? Yes, first you have to take first data, that is 3. How will you extract 3 from 63? Yes, you can perform the AND operation with 0FH so that we can extract the lower. This is called masking. So you can mask the one of the bits and you can get the data. So here if you mask the upper nibble and get the lower nibble. So masking can be done using AND operation. If you AND this with immediate data 0FH, then you will get 3 as your result. So after masking, you will get the first bit. If you mask the second byte, then you have to AND it with F0. So then you will get the upper byte. So after getting the lower byte and upper byte, you can store it. So let us see how masking is performed. So for example, for masking we will use either F0 or 0H. Say for example, what was your data? Your data is 63. So 63 can be represented as 0, 1, 0, 1. So this is 0, 1, 1, 0. And the lower is 0, 0, 1, 1. 6, it's a binary representation of 6, 0, 1, 1, 0. And binary representation of 3 is 0, 0, 1, 1. So if you want to mask the lower nibble, then you have to give f 0 f. Mask the upper nibble and get lower nibble means you have to get AND with 0 f. So what happens if you perform hand operation? So these all things will be 0. Lower upper bytes nibble will be 0 and the lower nibble will be given 1 1 1 1. So what happens after performing the AND operation between them? So after you perform the AND operation between them, what happens? Yes, and 1 0 AND with 0 is 0. 1 AND with 0 is 0. This is 0 and again 0. So what about this? 0 AND with 1 is 0, 0 and 1 AND with 1 is 1 and 1. So what is the result that you get? That is 0, 3. So you had given 63. After masking you got 6 and 0 and 3. So that is upper nibble has been masked and you have got the lower nibble. Similarly, if you want to get the upper nibble, then with what you have to AND? You have to AND with F0. So see what happens if you AND with F0, 63 contents. If you AND with F0, what happens? So F is 1 1 1 1 and then 0 0 0 0. So now I am performing AND operation between this and this. So perform AND operation 0 with 1. If you perform AND operation between them, what happens? So here with this you will perform AND operation. So 0 with 1 is 0. Again 1 with 1 is 1. 1 with 1 is 1. 1 with 0 is 0. And again lower nibbles will be, if any one of the inputs is 0, output will be 0 in for AND operation. So what is the thing that you got? 6 0. So if you give 63, you are getting 6 0. So that is 3 is eliminated and you have got only 6. So this is how you can mask. So now let us execute this here. So what is the thing we have to keep in mind? So one thing we have to keep in mind is if we give 63H, we should get 6 and 3. Mask packed BCD to unpacked BCD. So here I am planning to store my result input at 43, providing my input at 43. So 40H memory location, the data is 63 and storing my results at 30H and 31H. So first let me take the data. I'll start with origin. So next I am taking my data. So I am planning to give my data at 40H memory location. So move A comma 40H. So I have got my data. So now what I have to do? I have to mask this. For masking can be performed using AND operation. So ANL perform logical AND operation between which contents? Yes, A comma. First you can extract either upper bit or lower one. So which one shall we extract? So here in this program, which one they have extract? They have extract the upper byte. So they have extract the upper byte. The first upper byte, if you want to extract the upper byte, what do you have to do? So you can AND it with F0. And if you AND it with F0, you will get what? You will get 60, not 06. So hence what you have to do, after getting that you have to swap A. So that 60 becomes 06. Now I have to store this. Where I have to store? Where am I planning to store? So here, so I am planning to store it at 30H memory location. So what I have to do? I have to move this data into 30H memory. Now I have to again perform the same operation to get my second nibble. So what I have to do? Now I have to AND with Which one? Yes, A comma immediate 0fh. So what happens if I AND with 0fh? I will get the lower nibble. So lower nibble where I am planning to store? Lower nibble I am planning to store at 31h memory location. So do we want to have swap? No, because lower nibble is directly at the lower side. So move A comma, sorry, move 31h comma, we are going to store it 31h comma A, and then A. So let us compile this. And go to the debugger session. So where am I planning to give my input? So I have to give my input at 40h memory location and extract the output at, so at 40h memory location I am giving the data that is 63h. At 30h I should get my output, that is 6 and 3. So let us see what happens after execution. So first let us take the data. So the data is taken into accumulator, and then we are performing so AND operation between them with if a, so accumulator is stored with 06h 60h. Now I am perform swap operation. After performing the swap operation I have to store it. So storing is done at this one. So here we got 6, we have given 63, first one we have extracted upper nibble. So lower nibble we have to extract. Again get the data into the accumulator. We have got the data that is 63h, and now we'll perform the AND operation between them. After performing AND operation we will get 03h. So that can be directly stored into another memory location, that is the next memory location 31h. So I got 3h. So if I give 63, my output will be 6 and 3. So this is packed BCD to unpacked BCD. Next program. Program to convert ASCII to 2-digit packed BCD. So here we are going to provide ASCII values, then we have to get packed BCD. So here 6 and 3, ASCII value of 6 is 36, ASCII value of 3 is 33. So we will be providing 36 and 33 as the inputs. So the output should be packed BCD, that is 63. So ASCII value of 6, before we used to give 606 means it is 36 in ASCII. BCD 06 means 36 in ASCII. 3 means it is 33 in ASCII. So if we give 36 and 33, output should be 63. So how will you do? I am planning to give my inputs at 30h and 31h memory locations and expecting my result at 40h memory location. What is my first step? So I'll start with origin. So I'll take the first data into my accumulator and I'm going to mask this. I'm going to eliminate. I want to get only 6. Either you can perform subtraction or you can perform masking operation. So that is, I will eliminate this by masking. So ANL A comma immediate 0fh. Then what happens? So 3 will be masked and only 6 will be obtained. So 6 is obtained. Then what I will do? I have to get 63. So I have to swap it. So if you swap the contents of accumulator, 06 will become 60. And then I will get the next data. So I will store that data and get the next data. I will store that data in 40h memory location. Next what I will do? I will get the next data. I will perform the masking operation and masking with the next data 0fh. So 33, if you mask it, you will L3 will be eliminated and you will get only 3. So you will get 3, and that 3 should be performed OR operation between the contents of 40h. So let us try this here. So first I'll start with origin. So where I am planning to give my inputs at which location? I'm taking my first data. My first data is at memory location 30H. So next what I have to do, say this 36 out of this data 3 should be eliminated and I need only 6. So what I will do, I will perform AND operation. So ANL masking operation, that is A comma immediate 0FH. So 3 will be eliminated and I will get only 6. But I want it to be 60 because the result should be 63, right? 63, not 6 and 3. So I have to swap it. So now I will swap it, swap the contents of accumulator, it becomes 60 and I will store it in location move 40 destination H comma A. Now what I require? I require the next byte. So where is my next byte? At 31 memory location. So I will take move A comma 31H and I will again mask it because I don't want 33. I want only 3. So ANL A comma immediate 0FH, and now do we have to swap? No, 3 is the lower nibble, so don't have to swap. And so what do you have to do now? We can perform logical or add those 60 plus 3 becomes 63. So perform OR operation between accumulator and what is the, where have you stored the previous data at 40H memory location. Now I have to store my result back into 40H memory location, move 40H comma A. Performed result will be stored in accumulator, but the result should be stored in 40H. And the last instruction is end. So let's say now let's check the result. So where we are planning to give the input? So where we are planning to give the input? At 30H and 31H. So provide the input at 30H ASCII value. So ASCII value of 63 is 6 is 36 and ASCII value of 3 is 33. What should be my result? My result should be 63. So let us first take the contents. The first contents are taken into accumulator. Two instructions are executed simultaneously here. I have pressed the cursor twice. So two instructions are executed. So masking is also done. Now swapping will be done. And after swapping, the contents will be stored in 40H. Yes, contents is stored in 40H, that is 60. Now accumulator will take the next data, that is 33H. Now we will perform AND operation, that is masking operation, eliminate 3 and take only 3. So now we have 3. So what we have to do now? So we have to add the previous stored content 60 with 3 so that we will get 63. So now we got 63. That is in accumulator. So now that result has to be stored in this memory location. So again if you run, so that will be stored in memory location. So here I have given, not given 40H, I have just given 40. So 40 is a different memory location. So it takes it as a decimal. So not hexadecimal. So hence we have to give it as 40H or we have to search where it should be. The result is now stored at 40. It is decimal, not the hexadecimal. If you check, so see here, this is the result 63H. If you don't provide H here, then it becomes a decimal number. If you provide H, then only it will be hexadecimal number. So my result, if I give input 36 and 33, ASCII value 6 and 3, binary decimal value is 6 and 3, ASCII value is 36 and 33, my result is 63. So result is stored at this memory location because I have not placed H here. If we don't place H, it will think it as a decimal number. So this is my result. My result is stored at 40 decimal location. That value is 63. Now the next program is program to convert 2-digit packed BCD to ASCII. So we will be providing packed BCD and that has to be converted into ASCII. How will you do? Yes, first you will mask, take the bits individually, and then what you have to do, you have to perform OR operation with the 30 and then you will get the results. The results must be stored in the destination. So you will just mask them, take the individual nibbles and then OR them with 30 and then you will get the results. See here, so they have started with origin, move A comma 40, they have taken the contents of A will be replaced with the data that is pointed by 40H memory location, that's 63, and then we are going to perform a masking operation. Out of 63 I require only 3, so I have masked with 0F. So then this is 3, I don't want 3, it should be 33. So what I should do, OR with 30 or the contents of accumulator with the 30 and store that result where I want to store at 31 memory location. Similarly again I will take the data that is present at the 40H memory location. Again now I have to mask upper, I want the upper one, so I will mask it with F0. Then what you will get, you will eliminate 3 and you will get 6, but you don't want 60, you want 6, that is why you have to swap it. So now you got 6, after getting 6 you have to OR it with 30H, so you will get 36H and that 36H will be moved into which location, 30H memory location. Let us check this. So where are we providing the inputs? We are providing the input at 40H memory location. Don't forget to put H. Okay. So input is provided at memory location 40H. Okay. Next, what we have to do? We have to extract individual nibbles. So let me take anything. You can take either upper nibble or lower nibble first. For in this program, what they have taken? They have taken the lower nibble. So it is not that you have to take the lower nibble. You can also take the upper nibble. So perform masking operation and with A comma immediate. With what you are going to do? Immediate 0FH. So you will get lower nibble. So next what you have to do? So you have got out of 63 you got 3, but you have to get 33. ASCII value is 33. So hence what you have to do? You have to perform OR operation between A and immediate data 30H. So now you have got the result. Now you have to store the result at memory location. Now you have got 33. You have to store it. Where will you store? So we are storing at memory location. Where is the memory location that we have to store in this? We are going to store it as 31H. So 33 should be present at 31H. So move 31H. Destination is 31. Accumulator has the data. Okay. Next what you have to do? Take the second. So that is why move A comma 40H. The same data I will take again. Now I have to, out of 63, what do you have to take? I have already converted the lower nibble into ASCII. Upper nibble I have to convert it to ASCII. What I have to do? You have to mask. So what you will do? You will mask with ANL A comma immediate F0H. If you mask, you will get 60. So you don't want 60, it should be 06. So you will swap it. So you will get 06. Now it should be ASCII. So you have to add it. So you will perform OR operation with A with immediate data 30H. Now where you have to store? So you have to store this at which location? 30H. 30H comma A. And last instruction is end. Save this, compile this and build this and debug. So where should I give the input? So I have to give the input at 40 memory location. So it is 40H memory location. So at 40H memory location I will give 63. What should be my outputs? It should be 36 and 33 at memory locations 30H and 31H. So I have given the data. Now we will start line by line. Now the first data will be taken into accumulator and then AND operation is performed, and so that you will get masking is done, so you will get 3. Now we have to get 33 because ASCII value of 3 is 33. So you have performed OR operation. So you got 33. Now I have to store this. Storing of this will be done at memory location 31H. So after execution of this, you get 31H here. At 31H you will get the 33. Now again you have to take the data. A is loaded with 63. Now you will eliminate the lower nibble and retain the upper nibble. So you will perform AND operation with F0. You perform AND, you got 60. Now what you do? You have to get 6, not 60. So what you will do? You will swap it. After swapping you will get 6. Now what you have to do? You have to add 30. So you will perform OR operation. So now you got 36. So now that 36 has to be stored in 30H memory location. So this is 30H memory. So if you give 63, your output should be 36 and 33. So this is conversion of packed BCD to ASCII value. So what all we discussed in this session? So in this session we have used all the code conversion programs, and hence we have understood the concept of masking, and we have also used OR operation, AND operation and swap operations. So these are the MCQs of session 15. First one, ASCII stands for option A, American Standard Code for Interchange of Information. Option B, American Standard Code for Information Interchange. Option C, American Substitution Code for Information Interchange. Option D, none of the above. Yes, it's option B, American Standard Code for Information Interchange. Second one, BCD stands for option A, binary coded decimal. Option B, block coded decimal. Option C, binary code description. Option D, none of the above. What's the answer? Yes, BCD is binary coded decimal, option A. Third one, if A is equals to 66H, what happens to the contents of A register after execution of ANL A, immediate 0FFH instruction? What happens? Option A, accumulator will have 0FFH. Option B, accumulator will have 66H. Accumulator will have 00H in option C. Option D, accumulator will have 06H. What happens? Yes, if you add 66H with FFH, you will get the same data. So it is option B, accumulator will have 66H. Fourth question. Dash instruction is designed to convert the BCD addition problems. Option A, DAA. Option B, ADD. Option C, ADDC. Option D, none of the above. BCD addition, which instruction will be used? Yes, DAA instructions will be used for correction of BCD addition. Fifth one, ASCII value of 9 is, what is the ASCII of value of 9? Option A, 39. Option B, 9. Option C, 90. Option D, 49. What's the answer? Yes, ASCII value of 9 is option A, 39. These are the solutions for the MCQ. Thank you.